There is currently no electrical code that mandates computer printer manufacturers to adopt arc fault circuit interrupter, or AFCI, technology in their products. AFCI requirements are primarily concerned with protecting dwelling unit branch circuits and are intended to mitigate the risk of electrical fires. Computer printers, as a category of electronic device, do not fall under these specific AFCI mandates. The National Electrical Code, or NEC, which is a widely adopted standard for safe electrical installation, outlines the requirements for AFCI protection in specific areas of residential buildings. These areas typically include bedrooms, living rooms, dining rooms, family rooms, recreation rooms, libraries, and similar rooms and areas. The purpose of AFCI breakers is to detect arc faults, which are unintended electrical discharges that can occur due to damaged or deteriorated wiring, loose connections, or other electrical malfunctions. These arc faults can generate significant heat and are a leading cause of electrical fires. When an AFCI breaker detects an arc fault, it quickly interrupts the circuit, cutting off the flow of electricity and preventing the arc fault from escalating into fire. The NEC specifies the types of circuits that require AFCI protection, the locations where AFCI protection is required, and the performance standards that AFCI breakers must meet. These requirements are designed to provide a comprehensive layer of protection against electrical fires in residential occupancies. While computer printers and other electronic devices can potentially be a source of electrical hazards, they are typically addressed through product safety standards and testing requirements, rather than through direct mandates for AFCI integration. Product safety standards, such as those developed by Underwriters Laboratories, or ALL, and other organizations, establish requirements for the design, construction, and testing of electrical and electronic products to ensure that they meet minimum safety standards. These standards address a wide range of potential hazards, including electrical shock, fire, and mechanical hazards. Manufacturers of computer printers and other electronic devices are typically required to comply with these product safety standards, and the products are often tested and certified by independent testing laboratories to demonstrate compliance. This certification provides assurance that the products have been evaluated and found to meet the applicable safety requirements. Furthermore, general electrical safety practices such as proper wiring, grounding, and overcurrent protection also contribute to reducing the risk of electrical hazards associated with computer printers and other electronic devices. Proper wiring ensures that electrical circuits are properly installed and maintained, minimizing the risk of loose connections, damaged insulation, and other wiring defects that can lead to arc faults. Grounding provides a low impedance path for fault current to flow back to the source, helping to quickly trip over current protection devices, such as circuit breakers or fuses, in the event of a ground fault. Overcurrent protection devices are designed to protect electrical circuits from excessive current flow, which can be caused by short circuits, overloads, or other electrical faults. These devices interrupt the circuit when the current exceeds a predetermined level, preventing damage to equipment and reducing the risk of fire. In summary, while AFCI protection is not specifically mandated for computer printers, these devices are subject to product safety standards and general electrical safety practices that help to minimize the risk of electrical hazards. The NEC focuses on AFCI requirements for dwelling unit branch circuits to safeguard against potential electrical fires, and computer printers are addressed through different regulatory mechanisms and safety guidelines. The rationale behind the NEC focus on dwelling unit branch circuits for AFCI protection stems from several factors. Firstly, residential occupancies are often occupied by individuals who may be less familiar with electrical safety practices compared to trained professionals in commercial or industrial settings. Secondly, residential wiring systems tend to be older and may be more prone to deterioration and damage over time, increasing the risk of arc faults. Thirdly, residential fires can have devastating consequences due to the potential for loss of life and property. Therefore, the NEC prioritizes AFCI protection in residential occupancies to provide an additional layer of safety and reduce the risk of electrical fires. It is important to note that while AFCI protection is not specifically required for computer printers, it is still good practice to use surge protectors and other power conditioning devices to protect sensitive electronic equipment from voltage fluctuations and power surges. These devices can help to extend the lifespan of computer printers and other electronic devices and prevent damage from electrical disturbances. Additionally, it is essential to follow the manufacturer's instructions for proper installation, operation, and maintenance of computer printers and other electronic devices to ensure safe and reliable performance. This includes using the correct power cords, avoiding overloading electrical circuits, and regularly inspecting for any signs of damage or wear. Furthermore, it is crucial to be aware of the potential electrical hazards associated with computer printers and other electronic devices and to take appropriate precautions to prevent accidents. This includes avoiding contact with live electrical parts, keeping electrical cords away from water and other liquids, and unplugging devices when not in use. By following these safety guidelines, individuals can minimize the risk of electrical shocks, fires, and other electrical hazards associated with computer printers and other electronic devices. In addition to the above-mentioned points, it's important to consider the evolution of electrical safety standards and technologies. The NEC is regularly updated to incorporate new technologies and address emerging safety concerns. As technology advances, it is possible that AFCI requirements may be expanded to include other types of equipment or locations in the future. Therefore, it is essential to stay informed about the latest electrical codes and standards to ensure compliance and maintain a safe electrical environment. Moreover, the development and adoption of new technologies such as smart circuit breakers and advanced arc fault detection algorithms may further enhance electrical safety in the future. These technologies have the potential to provide more precise and reliable arc fault detection, reducing the risk of nuisance tripping and improving the overall effectiveness of AFCI protection. In conclusion, while there is currently no specific code mandate requiring computer printer manufacturers to adopt AFCI technology, electrical safety is a multifaceted issue addressed through a combination of product safety standards, general electrical safety practices, and specific requirements outlined in the NEC. AFCI protection is primarily focused on dwelling unit branch circuits to mitigate the risk of electrical fires in residential occupancies. However, computer printers and other electronic devices are subject to product safety standards and general electrical safety practices that help to minimize the risk of electrical hazards. By following these guidelines and staying informed about the latest electrical codes and standards, individuals can ensure a safe and reliable electrical environment. Consider an example where a homeowner experiences frequent tripping over an AFCI breaker in a bedroom circuit. After investigating the issue, it is discovered that the tripping is caused by an older computer printer that is connected to the same circuit. The printer's power supply is generating excessive electrical noise, which is being interpreted as an arc fault by the AFCI breaker. In this case, replacing the older printer with a newer model that has a more efficient power supply could resolve the issue. Alternatively, installing a line filter or surge protector between the printer and the electrical outlet could also help to reduce the electrical noise and prevent the AFCI breaker from tripping. This example illustrates how electrical devices can sometimes interact with AFCI breakers in unexpected ways, and it highlights the importance of understanding the potential causes of AFCI tripping and taking appropriate steps to resolve the issue. Furthermore, it underscores the need for ongoing research and development in the field of arc fault detection to improve the accuracy and reliability of AFCI breakers and minimize the occurrence of nuisance tripping. In addition to the technical aspects of AFCI protection, it is also important to consider the human factor. Electrical safety is not solely dependent on technology, it also relies on the knowledge, skills, and behaviors of individuals who work with and around electricity. Therefore, it is essential to provide adequate training and education to electricians, contractors, and homeowners on electrical safety practices, including the proper installation, operation, and maintenance of electrical equipment and systems. This training should cover topics such as electrical shock hazards, arc flash hazards, proper grounding techniques, and the importance of using personal protective equipment, or PPE, when working with electricity. By promoting a culture of safety and empowering individuals with the knowledge and skills they need to work safely with electricity, it is possible to significantly reduce the risk of electrical accidents and injuries. Consider a scenario where an electrician is tasked with installing a new electrical outlet in a home. Before starting the work, the electrician should first energize the circuit by turning off the corresponding circuit breaker at the main electrical panel. The electrician should then use a voltage tester to verify that the circuit is indeed energized before proceeding with the installation. This simple step can prevent accidental electrical shock and potentially save the electrician's life. During the installation, the electrician should ensure that all wiring connections are tight and secure, and that the electrical outlet is properly grounded. The electrician should also follow all applicable electrical codes and standards to ensure that the installation is safe and compliant. After completing the installation, the electrician should test the outlet to verify that it is working correctly and that there are no electrical hazards. This scenario highlights the importance of following basic electrical safety practices and procedures to prevent accidents and injuries. In addition to training and education, it is also important to promote awareness of electrical safety hazards and to encourage individuals to report any potential safety concerns. This can be achieved through public service announcements, safety posters, and other outreach efforts. By raising awareness of electrical safety hazards, it is possible to create a more informed and safety-conscious public, which can help to prevent electrical accidents and injuries. Consider an example where a homeowner notices a frayed electrical cord on a lamp. Instead of attempting to repair the cord themselves, the homeowner should immediately unplug the lamp and either replace the cord or have the lamp repaired by a qualified electrician. This simple action can prevent a potential electrical shock or fire hazard. Furthermore, the homeowner should report the frayed cord to the landlord or property manager so that they can take steps to address the issue and prevent similar problems from occurring in the future. This example illustrates the importance of being aware of potential electrical hazards and taking appropriate action to address them. In summary, electrical safety is a shared responsibility that requires the combined efforts of individuals, organizations, and government agencies. By promoting a culture of safety, providing adequate training and education, raising awareness of electrical safety hazards, and enforcing electrical codes and standards, it is possible to create a safer electrical environment for everyone. It is important to recognize that electrical safety is an ongoing process that requires continuous improvement and adaptation to new technologies and challenges. By staying informed about the latest electrical safety practices and technologies, and by working together to promote electrical safety, we can all contribute to reducing the risk of electrical accidents and injuries.